Let's talk about using a ContinuuMini, though you could also use a Continuum, to play a monophonic synth through the Continuum voltage converter CV interface. First, why not use a MIDI to CV converter instead? Well, you can, but you just won't get the same smooth analog sounding translation of the ContinuuMini or Continuum output that you're used to from playing the Continuum. If you have a synth or sound module that accepts CV pitch and volume, also gate and perhaps filter sweep or modulation CV input, you'll get much more natural fingerboard translation using CV. We'll mostly discuss using the ContinuuMini and Evaton Technologies uCVC in this video, but the same configurations and programming apply to using a half-size, full-size, or Slim Continuum with Haken Audio's CVC that we'll also take a look at. Here are your two options for connecting a ContinuuMini or Continuum to a control voltage source. Because the Continuum and ContinuuMini use a proprietary I2C CV interface, you must use one of these two options to connect up to CV equipment. Now for the ContinuuMini, if you have Eurorack equipment, the Evaton Technologies uCVC is ideal because it is geared to playing monophonically, and most of the time you'll play monophonically on a ContinuuMini. So you'll need one uCVC module that will put out W, X, Y, and Z finger positions. The uCVC also puts out an additional F finger position. When your finger is in contact with the fingerboard, it'll put out 8 volts. Otherwise, the W, X, Y, and Z outputs are identical to what the Haken Audio CVC does. If you're playing monophonically, then you only need one of these uCVC modules. If you want to play duophonically, you can buy another one, and they daisy chain in the back of your Eurorack setup, and you'll then be able to play 2-voice ContinuuMini output over CV. Now, if you don't have Eurorack or you have a regular Continuum, you can get the Haken Audio Continuum voltage converter. This is a larger unit. By the way, this is not to scale on this screen. The Haken Audio CVC can be rack mounted or set on a tabletop, and that supports 4 separate sets of W, X, Y, and Z. So you can theoretically play 4-voice polyphony on a CVC if you have enough CV modules to support 4-voice polyphony. Both are programmed identically in the matrix. Both work the same because the Continuum is outputting the same CV output to each. The only thing to possibly remember is that on the current generation Haken Audio CVCs, it now has a TRS connector that will allow you to easily connect up to ContinuuMini and Slim Continuums that have a TRS CV output. The half-side and full-size Continuums, you'll have to connect up to the MIDI connections as you did with the previous generation CVC that did not have this TRS connection. They operate exactly the same way. It just means you'll need a different cable for a half or a full-size Continuum, whether you use a Continuum voltage converter from Haken Audio or the uCVC. There are separate cables for ContinuuMini and Slim Continuums, and the half and full size for that too. When you order a uCVC, just ask for the appropriate cable. Now, how do you hook up your ContinuuMini to a uCVC? On the ContinuuMini, the pedal external output is used to connect the pedal and also to connect up to the CV. What you'll do is go into the menu system, pressing the octave plus and minus buttons together, and then scroll to the I2C option and set that from its default 0, which means you're using a pedal, to 1, which means you'll use CV. Then you can just press octave plus and minus together to exit the menu system. Then bring up your editor, and if you go to the control voltage converter option, you'll see that it will be connected if you've set things up correctly. If not, this will say CVC not connected. Also, in the newer editors, the post 9.0 editors, you'll have a DSP usage message up in the top right-hand corner. That will also give you an indication that the CVC is connected by a 1 there. It'll be blank if no CVC is connected. The ContinuuMini doesn't know that this is a uCVC or a Haken Audio CVC. Same difference to the ContinuuMini. You can go to your CVC section and bring up the options now, once you've verified you've got that CVC connected. Some Eurorack equipment might want 10-volt connections, some might want 5-volt. You might have some other piece of equipment like a Buchla that doesn't take a 1-volt per octave X output, but a 1.2-volt per octave output. You have some default configurations that you can select from here. It'll tell you what your gate voltage output will be. For the first option, gate voltage is 10 volts. Then it'll tell you what note number, what MIDI note number, and then 60 here is going to be 0 volts on the 1 volt per octave scaling. Then it will show you your Y voltage scaling, in this case 0 to 10 volts from min to max on Y, and your Z voltage scaling here is 0 to 10 volts if you press maximum on the fingerboard. There are other options that you can see, and if one of these does not suit your equipment, you can program the CVC in the EaganMatrix. We'll take a look at that in a second. There are some other options you can set for the CVC. You can set whether it's going to use linear or squared Z values. Again, you can change this to even other things if you program it yourself. You can specify whether the CVC is going to output normally or whether it's going to basically output on all the CV channels. This is a more Haken audio CV function. It obviously won't apply to a single uCVC. And then you can tell it what bass voice is going to output on. Normally this will be set to 1. If I'm playing monophonically on a Haken audio CVC, if I set this to 2, for example, the second set of CV channels are going to be played even though you're playing monophonically. So these can be useful for certain things, but most all the time you're only going to be interested in setting your basic CV type and then maybe whether you want to use a linear or a square Z value. As we said, if you are using a uCVC and you want to play duophonically through Eurorack, you can buy another one, daisy chain them together as in this drawing. You can get the manual from Evaton Technologies that has a lot more information, but basically one of these becomes a master, one becomes a slave. The master's LED is always lit so you know which one's the master. This could be valuable if you want to play duophonically on 2 separate CV interfaces. I'm going to play a Moog Slim Phatty using the ContinuuMini over a uCVC interface for this video. In setting this up, I noticed that the Moog synth does not actually take a 1 volt per octave X input. It's slightly off of that. Unfortunately, there is no option for this in the default CVC settings. Most all of them are 1 volt per octave, and there's a Buchla 1.2 volt per octave setting. So in this case, I have to try and program the CVC myself to accept an X input that's going to scale correctly. How am I going to do that? I have the matrix up here connected to a ContinuuMini, and if you noticed, on bank B, there's a CVC custom control voltage option. There's also one available on bank C if you need it. If you select one of these banks, when you go to look at your control voltage converter status, it's going to show you CVC via matrix as opposed to just CVC connected. So now I know I'm ready to program this in the matrix. If you go to your system categories, this is in the new editor, you'll see a number of predefined CVC presets that you can load up. Well, I've loaded one of these up and I've changed it a bit. So how does this work? Well, when you define CVC to be programmed in the matrix, you can program up to 8 control points on the CVC. Or if you only have a uCVC connected, you'll only be able to program 4 of them. I can apply formulas in the matrix. So the first CVC control option is going to apply to the first W gate. Number 2 will apply to X on the first set of CVC inputs. Number 3 will apply to Y. Number 4 will apply to Z. And then you have a second set if you want to program them. That will be 5 going to W, X, Y, Z, 6, 7, 8 in corresponding fashion. If I only have the one uCVC, the first 4 are going to apply to W, X, Y, and Z. The CVC doesn't know anything about this F option on the uCVC. So I can apply normal EaganMatrix formulas, A, B, C, D in this case, and the A formula is going to apply to my gate, the B formula to my X pitch, the C formula to Y, and the D formula to Z. Let's go back and look at these formulas. A has been defined as a 10-volt gate. Let's say I want to have a 7.5-volt gate. I could do that by simply changing W in the matrix here as I'm programming the CVC. If you program this more than 10 volts, it's going to clip at 10 volts, by the way. So I can change the value of W. Now on B, my X finger position, what I've done here is I've scaled it a little differently than the default. The default for 1 volt per octave would be X going -1 to +1. The values, obviously, that I'm putting in here are volts. It just turned out when I was playing around with the Moog Slim Phatty, I had to scale this -1.1 to +1.1 with a little bit of trim offset, 0.15, to be able to get this to conform to a nice octave scaling. And I kept this set on the octave, so I'm scaling per octave. I could set this to some other option, and then I would be dealing with raw voltage scaling, which might not be really what you want for scaling notes correctly, but you could theoretically do that to get some kind of strange CV pitch interface if you wanted to. So C applies to Y, is using a standard linear scaling with a little bit of shelving on it. I could change this to any one of the shapes that I wanted. I could step voltage through Y through different values. Very flexible in the way you can program this. And Z now, my D formula, that is just a linear scaling from 0 to 10 volts if I press as hard as I can on the fingerboard. Of course, I could set this to any one of the other Z scaling options as well. I think you can see a very, very flexible option that's available for programming the CVC in the EaganMatrix. It's quite a unique and flexible interface for the CVC. I know nothing else like it. So I'll go into the Moog manual and I see that it wants a keyboard gate of 5 volts, so I'll set W to 5. My pitch I've already tested out is okay. It wants a volume CV of 0 to 5 volts, so I'll set my Z to 0 to 5, and it wants a filter CV of -5 to 5 volts, so on Y I will go and set this -5 to 5, and that should match the specs of the Moog. What I'll do is I'll save this so I have it on hand, and I'll control click it back into my preset slot, and I should be set for CV for the Moog Slim Phatty. So we can connect up our uCVC to our ContinuuMini with this special cable that you'll order when you order your uCVC. Just tell them that you want a ContinuuMini interface. You can use the F finger output if you want to, but what you're going to want to do is, in this case, let's say we want to connect up to a Moog Minotaur. Similar connections as a Slim Phatty. There's a pitch CV, there's a filter CV, a volume CV, and a gate. So you'll connect up W to your gate, you'll connect the X to the pitch CV, you'll connect the Y to your filter control, and you'll connect the Z to volume. Now we will have to talk about later the use of Y in a ContinuuMini because there's not very much Y space here. And if you have a preset that's going to have a lot of filter sweep on it, you really won't be able to get the full effect of that on a Mini, which may give you a little bit of discontinuity because of the small Y distance here. You can get around that by going into the matrix and reprogramming Y to have a little less range that maybe give you a better output. Here's a similar setup with a ContinuuMini if I want to play a Moog Slim Phatty. Same inputs as we just saw with the Minotaur from a Haken Audio CVC. I'll connect up W, X, Y, and Z the same way I did with the uCVC, and I'll connect up my ContinuuMini to the TRS interface of my CVC. Set it to the I2C1 setting as we discussed earlier. Now the actual setup that I'm using for this demo is to connect my ContinuuMini to the uCVC as we just discussed. That's connected to a Slim Phatty. The audio out of the Slim Phatty I'm actually processing with an IntelliGel audio I/O card, so I can turn that into stereo inputs to my Behringer A to D converter that I'm going to send the digital input into the SPDIF jack of a Slim Continuum so I can process the audio with Continuum reverb. You could certainly take the audio output of your synth and send it through some kind of effects processor to a mixer. A million options here. But since I have these continuums available, I'll use my Continuum onboard reverb as the sound effect processing for this demo. Finally, because we're playing a monophonic synth and we're doing it from a ContinuuMini that will output two voices if you press two fingers down at the same time, we want to make sure that we set polyphony to bass 1, not bass 1 plus, bass 1. That way, I'll guarantee that I'm only going to play monophonically and I won't have any cutouts or overlaps that will result in basically silences in the playing when the second voice is coming in and the CVC is not capable of playing a second voice in this case. And as I said, I'm running the digital converted output of the Moog into my Slim Continuum and processing it with reverb in the recirculator there. And this programming for that is to simply route Unity AES left-right signal to SLSR and turn up your audio in or the AES input on the 9.0 editor, and that will apply the reverb to the incoming signal. And if you're new to using CV, you need to go into your oscillators or your synth and fine-tune the synth to the fingerboard if you want to play the right notes. So here's another issue that perhaps we might want to talk about. I've actually connected the Slim Continuum to the uCVC instead of the Mini to start. It's exactly the same connector. I've set a preset on the Slim Phatty, and I noticed when I had this set to the default -5 to +5 voltage that's in the manual, I'm not getting anything coming out on my filter sweep below 0 volts. So I'm not sure if that manual is in error or not, but it's simple to correct. I'll just set my voltage formula to 0 to 5 volts. Now I get a full sweep across the full range of Y. But now we have another thing to talk about, and that's a pretty nice sweep that I can get on the Slim because I have so much Y space. When I'm on the Mini, we'll connect that up in a second now and see how this sounds on that. I'm going to have a lot more difficult getting that full Y sweep on such a small Y space on the Mini. Also on the Slim, because I've set this into a mono mode, I can get a monophonic sweep by altering the pressure on my fingers. And there are monophonic modes that could be set on the Slim or a half size or a full size Continuum. It would work the same way. That's not available on the Mini, so there is that one limitation too in terms of monophonic playing on a Mini, that you can't get this monophonic portamento based on pressure on the Mini. You can do it by simulating that with a sweep on the fingerboard, of course. Okay, we have our Mini connected up. Same preset we were using before. Let's test out the Y on this. I've reset it, you can see, from 0 to 5 volts the way we did with the Slim, so I'm getting that full sweep, but of course, if I'm just playing normally now, I can get some discontinuities because I can cross that filter sweep so quickly. So maybe what I want to do is go in here, and though I might not get the full range of sweep, if I reduce the sweep range a bit, and I can set it, you know, above 0, anywhere I want to get something that maybe will let me play notes, still have a sweep, but not get so much discontinuity. One other example of why it's so important to learn how to program CV in the Matrix, especially if you're using a Mini with CV, because then you can fine-tune filter sweeps, Z, Y, whatever, to the Mini itself. And now I can probably go see what else I can do, what other presets there are. Some of them are going to be louder than others. There's one that's got 2 tones playing. Let me sync them together. And I can go and, of course I set it monophonically. If I try and play 2 notes at one time, it's going to kick in the first one it sees and use that, so I don't have to worry about dual phonic discontinuities. You can hear I can't get that monophonic portamento sweep on a Mini. It'll go immediately to the next note. So if I want to get a kind of a sweep, I'll have to do it on the fingerboard itself. No big issue there. I don't think you can create as fast or slow a sweep as you want. You're still going to get that truly continuous sounding portamento because we're using CV. If I tried to do this with a MIDI conversion, I might get some stepping in there that would not be acceptable. And of course I can use the octave buttons. And they'll kick in just fine with CV as well. There's another one. I'm getting some discontinuity. I might want to fine-tune my Y there. I can go octave up as well. And there you have it. Set your Mini, or if you're using a Slim or a half or a full size and you're playing a monophonic instrument, set them for Polyphony 1, connect up your CVC, use a default if it will work for you. If not, go into the Matrix and program the CV yourself, and you should have a fun time now connecting up your continuums to virtually any CV source.